Today we're going to talk about two different kinds of numbers. These are all positive numbers and whole numbers, but they can be divided into two categories that you may or may not have heard of before. I think you have heard of prime numbers. But numbers that aren't prime are called composite numbers. You already know what factors are. They're numbers that go evenly into a number. So they define it as numbers that multiply together to create another number. For example, 2 and 3 are factors of 6 because 2 times 3 equals 6. Also, you can think of it as 6 divided by 3 is 2, 6 divided by 2 is 3. So they divide evenly or go evenly into 6. That also makes them factors. So the challenge is, can you write all the factors of 12? So when you're trying to find all the factors of a number, I always recommend starting with 1 because 1 is a factor of every number. So 1 and 12, because 1 times 12 is 12. Then just go up to the next number, see if it works. 2, yeah. 2 times 6 is also 12. So we've done 1 and 2. Let's try 3. 3 times 4 is also 12. And you can stop there because one cool trick, I've gone 1, 2, 3. My next number would be 4, but if you look, I've already used 4. So I know from here on, anything I find would just be a repeat. And we don't need to do 4 times 3 or 6 times 2. There's no difference in them. So once you get up to a number you've already used as the second number, you know you're done. And you can list them like this. You can also list them in numeric order and say 1, 2, 3, 4, 6, 12. So either way, those are the factors of 12. So a prime number. Now we're not going to go this route right now, but just so you know, prime numbers are actually a huge key to security codes, whether it has to do with credit cards, whether it has to do with cybersecurity, so they protect our personal information on a website. Prime numbers are a huge part of coding and encoding things to keep them private. But a whole number greater than 1, whose only factors are 1 in itself. So notice right away, 1 is not a prime number. A whole number greater than 1, whose only factors are 1 in itself. So 3 is an easy example, because the only thing that go evenly into 3 are 1 and itself, 3. So then you take a second, see if you can think of 3 other prime numbers. There are lots of them. I'll just do some smaller ones. You may have picked different ones, but 5 is an example because it's only 1 and 5 that go into it. 11's an example because only 1 and 11 go into it. 23 is also an example because only 1 and 23 go into it. Now I skipped some in between, like 7 is in between 5 and 11. 17 and 19 and 13 are some between those. So I wasn't going in order, but those are examples of prime numbers. So if it's not a prime number, then it's a composite number. A composite number is a whole number greater than 1 that has more than 2 factors. For example, 4, because we can do 4 times 1 and we can do 2 times 2. So if you look back at where we started, 12 is certainly a composite number because it had 6 factors. That's far more than 2. Whereas these, their only factors are 1 times 5, 1 times 11, 1 times 23. So see now if you can think of 3 other composite numbers. Okay, 6 is an easy example because it can have 1, 2, 3, and 6. So that's 4 factors. So it's definitely a composite number. Let's see. 14 would be an example, because 1, 2, 7, and 14 all go evenly into those. 20 would be another one, because 1, 2, 4, 5, 10, and 20 all go evenly into it. So when they have more than two factors, they're composite numbers. Now the one exception is the number 1. So this is the only positive whole number that's neither prime nor composite, because it really only has one factor. 0 is not prime or composite either, but I decided to just tell you it's only positive numbers we're dealing with. But really, for all of these, prime and composite, we're talking about 2 and greater whole numbers. Okay, I would encourage you guys to pause this video and try to fill this out on your own. So someone do that or get ready to do that while I explain. You're supposed to circle the primes and box the composites. So go ahead and pause. You try to circle the primes, box the composites. Then you can unpause when you're ready to try it out. Ready to see the answers. Okay, 1's neither, so I'm not going to box it or circle it. 2 is prime, its only factors are 1 and 2. 3 is prime, its only factors are 1 and 3. 4 is composite, 1, 2, and 4. That's 3 factors. 5 is prime, only 1 and 5. 6, as we already pointed out up here, is a composite. 7's prime, because nothing goes into it except 1 and 7. 8's composite, because 1, 2, 4, and 8 all go evenly into it, so that's, I think, 4 factors. 9's also composite, because 1, 3, and 9 go into it, so that's 3 factors. I'm not going to list all of them, but you can check them later. 10 is composite. 11's prime. 12 is composite. 13 is prime. 14 is composite. 15 is composite. 16 is composite. 17 is prime. 18 is composite. 19 is prime. 20, 21, 22 are composite. 23 is prime. 24 is composite. 25 is composite. 26 is composite. And 27 is composite. You don't have to, but I'd recommend trying to put these prime numbers into your memory. You don't have to go higher than that necessarily, but knowing the lower ones will really help you as we go through this. So, one other thing you can notice is all of the prime numbers except for 2 have something in common. If you look, every prime number, and this is true even beyond our list, except for 2 is odd. Every even number after 2 is composite, because if you think about it, every even number after 2 will always have at least 3 factors, because it'll have 1 itself, and because it's even, it'll be divisible by 2. So with the exception of 2, all of our prime numbers are odds. But of course, that doesn't mean every odd number is prime, because 15 is odd, but it's a composite. 21 is odd, but it's a composite, and so on. So I need to break here. We'll make a part 2 for this, and it'll complete the rest of the notes.